Hello everyone. In this session, we are going to see the guidelines for DSA. In this presentation, I'll explain what DSA is and why it is needed and its main guidelines. Introduction to DSA. The domain-specific architecture. DSA stands for domain-specific architecture. The domain-specific architecture are the processors designed for a particular type of work. Unlike CPUs, they do not try to do everything. They just focus on the particular work assigned for them and complete the task very efficiently. So, it has a high throughput and energy efficiency. In this CPU, GPU and TPU. The CPU are used for general programs, the GPU are used for graphics and parallel communication, and the TPU is used for deep learning. Example domain. In this seminar, the deep neural networks are taken as the example domain. DNNs need a lot of computation. They work on large data and they need high speed. Because of this, the special architectures like GPU and TPU are used for deep neural networks. The motivation for DSAs. The motivations earlier, the performance improved by increasing the processor speed, but now we cannot increase speed because of the power and the heat problems. At the same time, the modern applications need more performance. So instead of faster CPUs, we use specialized architectures like DSA. What is domain-specific architecture? A domain-specific architecture is designed for one specific type of application. It focuses only on frequently used operation. It removes unnecessary general purpose features. So, if a target is assigned for a domain specific architecture, it just focuses on what the domain is, what the specific topic has been assigned for it. So, it is designed for the such type of system applications, like is designed for one specific type of application. It focuses only on frequently used operations. It removes the unnecessary features, and because of this it gives better performance rather than any other CPUs, and uses less power. So let's move on to the guidelines of DSAs. There are 7 main guidelines for DSA. The guideline 1 is focus on a narrow and stable domain. The first guideline says that we should choose a domain that is well defined and stable. This means the type of work should not change frequently. Deep neural networks are a good example because their basic operations stay the same. Guideline 2. Exploit massive parallelism. So the most domain specific application do many similar operations at the same time. So DSA uses parallel processing. Many small processing units work together to finish work faster. The DNN is the most relevant example we can take for DSA. So we are seeing in context to DSA in the guidelines, and I have given the examples for it. Guideline 3. Minimize a data movement. So moving data from memory uses more power than processing data. So whenever you try to move a memory, uh, it uses more data, more power than processing the data. So the DSAs try to reduce the data movement between any systems, any processor, etc. So they reuse the data and keep it close to the processor. Example, the AI accelerators store model parameters locally to avoid repeated DRAM access. Guideline 4. Use specialized data types. So, not all the applications need very high precision numbers. Using smaller data types reduces power and improves speed. This is commonly used in AI applications. This improves the performance and efficiency, and also reduces arithmetic and lowers the power and area. Example, AI inference commonly uses 8-bit or 16-bit arithmetic instead of 32-bit floating point. Guideline 5. Simplify control logic. So, DSAs avoid complex instruction or control mechanisms. So, they use simple and predictable execution. This reduces hardware complexity and saves the power. When you avoid complex control mechanism, automatically the power between the transfers get lowered, so it has the high efficiency in a lowered power. So these DSAs are used for efficient management, and the perfect example for DSA is DNN. Guideline 6. The hardware software code design. In DSA, hardware and softwares are always designed together with compilers, frameworks, and etc. So these softwares understand the hardware structure and help in better optimization and performance. Example, machine learning frameworks are turned to fully exploit specialized AI hardware. So machine learning is nothing but you train a machine to do particular work, right? So whenever the hardware software co-design is used, the software always understand what is the hardware's need, hardware's processing units, and etc. So this helps in better optimization and better performance. And the last mm, guideline is optimize performance per watt. So today the power is more important than speed. So DSA focus on getting maximum performance using minimum power. This is called performance per watt. That means DSA, the domain specific architecture, always focuses on how the power is uh, less, or power is consumed very lesser. Like we saw in previous slides, it always lessens the power by memory movement cancellation, like that. So this is the main guideline for the DSA. It optimizes the performance by even though it lessens the power. So this makes the DSA very energy efficient, and performance per watt is the primary metric that makes the optimization very good. Advantages of a domain specific architecture. DSAs have high performance for specific application because they always consume less power, right? So they also use hardware resources efficiently rather than software resources. Challenges that we face in DSA. Since DSA always focuses on how to give an energy efficient performance with lesser power, it cannot be so flexible compared to CPU. So, because of this structure, they are very expensive to design. They also need special software support. So, it makes a challenge for a domain specific architecture design. Case study. GPU. A GPU is a good example of DSA. It has many small cores working in parallel. It is mainly used for graphics and machine learning. It is a very small case study which represents the GPU. It's a very good example of domain specific architecture. This GPU is mainly used for graphics and machine learning. It does not have a um, large working unit. It just have small cores working in parallel. So this is the GPU case study conclusion. And the GPU, TPU. In this case study, the TPU is specially designed for deep neural networks. It always focuses on the matrix operations and has the high performance with lower power. It also always focuses on how to cancel the memory movement, and um, has an alternate ways to always generate or get low power and generate high performance. So TPU are used. The conclusion is domain specific architectures are key response to slowdown of traditional scaling loss. To conclude domain specific architecture, we saw the limitation of it solves the limitation of traditional CPUs which take more time and more power for high performance, but it doesn't seem to show some more performance, so we use DSAs these days. But by following proper guidelines, they provide better performance and energy efficiency. So these are very important for modern application. Thank you.